In the name of Allah, the most gracious and the most merciful. Assalamu alaikum, my dear student. Me, Yasir Mahmood, your physics teacher. My dear student, I hope you all will be fine and enjoying good health. Dear students, from today onward, we are going to start our e-learning classes. Before starting a class, one thing you must be kept in your mind that the syllabus which we will cover during that e-learning classes will not be repeated again. Because you all know that there is only one way of completing our syllabus by means of the e-learning classes. So you all must be vigilant, be attentive, and be regular in your e-learning classes. Okay, my dear student. Dear student, we were discussing about the unit number 4, which is of the mass, weight, and density. In the previous topic, we had discussed about the mass. Now today we are going to start new topic, which is about the inertia. The student inertia is also related to the mass. Now, what is the inertia? It is a property of the mass which resists change from its state of rest or motion. It's called the inertia. Means when a body is at rest and if we want to move that body always be reluctant to move because of its mass, because of its inertia. On the other hand, if the body is moving and if you want to stop the motion of the body again be reluctant to stop. That is again due to its mass, due to its inertia. So we can say that inertia is a reluctance of an object to change the way in which it is moving. And if it's still, it stays still. And if it is moving, it carries on moving unless a force acts on it. Now we take an example. Let's suppose we throw a ball from the horizon from the inclined plane. Ball will move with a greater velocity. But if we bend that path in that way and in that way, you can see that ball will follow the bent path and the velocity will be decreased. Why the velocity will be decreased? Because of the inertia of that bent path. The greater will be the bend and lesser will be the velocity. On the other hand, if you ignore that bent path, the ball will move with a greater velocity in that direction. It means that the velocity of the ball decrease due to the inertia of that bent path. It means that we can say that the velocity of the ball also affected by the inertia of an object. Now everything which has a mass has inertia, but the massless body don't have inertia. Like we have a light, we have electricity, heat, and other form of the energy don't possess inertia. Now we will discuss the different types of the inertia. First is the inertia of rest. What is the inertia of rest? Inertia of rest can be defined as the inability of an object or a body to change its state of rest itself. Means a body will not change its state itself unless and until some external force exerted on it. Okay, my dear student, that is the inertia of the rest. Let's suppose we have a car and we have a truck. If you want to move both of them, obviously truck will require a greater force to move because of the larger mass, because of the greater inertia. On the other hand, car have a smaller mass than the truck, then it can be moved easily with a great speed. Take another example. Let's suppose when a car is suddenly started, the passenger in it fall backward. Ever you wonder why that happens? Well, the lower part, which is in contact with the car, comes in motion, whereas the upper part remains in rest due to the inertia of the rest. Now, what is the inertia of motion? Inertia of motion, inertia of the motion can be defined as the inability of an object or a body to change its state of motion by itself. Mean, let's suppose a body is moving. If we want to stop the motion of the cord, body will again be reluctant to stop. That reluctancy is due to its mass, due to its inertia. That is called the inertia of motion. If we reverse the previous example, let's say that you are in a moving car and when it suddenly stops, all the passengers fall forward. That's because the lower part of the body, which is in contact with the car, is at the rest, whereas the upper part tend to remain in motion due to the inertia of motion. That is the inertia of the motion. So we can summarize at inertia of the rest that the body can't change its state of rest by itself. On the other hand, in the inertia of the motion, body can't change its state of motion by itself. It means that if we want to change the state of the body, we must have to apply the external force. I mean, body cannot change its state without applying some external force, which we already discussed in the Newton's first law of the motion. That's why Newton's first law of motion is also called a law of inertia. There is another type of the inertia, inertia of direction, that the body can't change direction on its own, moving in the uniform motion. So these are the different types of the inertia. Now we take a common example. Let's suppose when a driver need to wear a seat belt when driving because of the effect of inertia. Because without the seat belt, if the driver suddenly applies his car brakes, he will continue to move forward due to the inertia and crash into the windscreen. On the other hand, if it wears the seat belt, the driver will be prevented by the seat belt from crashing into the windscreen. That is the advantage of using the seat belt. Okay, my dear student, that's it for the inertia. Now, our next topic is gravitational field strength. Before discussing gravitational field strength, you must have to know what is the gravitational field. Gravitational field is a region in which Earth attracts everybody towards itself. It is the gravitational field. Mean our Earth is a gravitational field. Come on, dear student, that is the definition of the gravitational field. That is a region in which a mass experienced by the force due to the gravitational attraction. Now, what is the gravitational field strength? Gravitational field strength is a gravitational force acting per unit mass on an object. Mean how much gravitational force acting on a body. It shows its strength of gravitational field. As the different planet had different gravitational field strength. Like that, the gravitational field strength on the Earth is 10 Newton per kilogram. Newton per kilogram is a unit of the gravitational field strength. What does it mean that Earth has gravitational field strength is 10 Newton per kilogram? It means that a 1 kg mass of an object has a force of 10 Newton pulling on it due to the Earth. On the other hand, the gravitational field strength of the moon is 1.6, means that the same 1 kg object on the moon only experiences the gravitational force of 1.6 Newton. And the gravitational field strength of the Mars, that is not a moon, 3.8, that is the gravitational field strength of the Mars that needed to be correct. Okay, my dear, that is the gravitational field strength on the Mars, 3.8 Newton per kilogram. Now next is weight. What is the weight? Weight of the object, the pull of gravity on the body. Whenever Earth attracts a body towards itself, it always exerted a pulling force. That force is called the weight, and it can be measured by the formula W will be equal to mg. M is a mass of an object, G is acceleration due to gravity. Beta, this gravitational weight is basically the gravitational force. That's why its unit is Newton. Okay, my dear student, not the kilogram. Now that we can use a different instrument to measure the weight, like that is the spring balance can be used to measure the weight, and the compression balance can also be used to measure the weight. Now the we know that as I told you earlier, that the weight is measured in Newton and it is a vector quantity because the weight of the body does not remain constant. According to Newton's law of gravitation, gravitational force is inversely proportional to the square of the distance from the center of the earth. So my dear student, now there is a big difference between weight and mass. Sometimes students confused about the weight and mass. Sometimes they treat both weight and mass as the same quantities, but they are not same. Now we will discuss the comparison between weight and mass. What is the weight? It is a pull of gravity on object. What is the mass? It is the amount of the matter in a body. On the other hand, it has magnitude and direction. As I told you earlier, it is a vector quantity. What is the mass? It has only magnitude but no direction. Now, it is measured in Newton, as I told you earlier, because it is a gravitational force, and the mass is measured in kilogram. Next, it can change from place to place. As I told you earlier that according to Newton's law of gravitation, acceleration due to gravity inversely proportional to the square of the distance from the center of the earth. Mean as we go away from the center of the earth, the value of the g will be decreases. Now it remains same in everywhere. Mass is a constant quantity and it can be measured, weight can be measured by means of the spring balance and the compression balance, which I told you earlier. On the other hand, mass can be measured by means of the beam balance or the electronic balance. These are the comparison between the weight and mass. That's it for today's lecture, my dear student. You must have to read that lecture completely, very carefully, attentively. If you have any queries, you can discuss in your WhatsApp group. Okay, my dear student, thank you. Allah Hafiz.